Hello students, today I will discuss about a very popular data structure, tree. Tree is one data structure generally used to represent hierarchical data. For example, let's say I want to show the faculty members with their hierarchical positions of our institute, and we get the structure something like this. You see, PKM is TIC and PKM can instruct two persons directly, AR and TC. Then AR, his designation is HOD BCA, can instruct two persons directly, RC and KS, as they are under the AR. TC also can instruct two persons directly, DM and BM, as they are under TC. This particular logical structure that you have been seeing here is tree. Here you see this structure upside down, and then it will resemble a real tree. The root here is top and we are branching out in downward direction. Logical representation of tree data structure is always like this: root at the top and branching out in downward direction. Tree is an efficient way of storing and organizing data in hierarchical form. And as you see, tree is a non-linear data structure. Okay, we move to the next. All the images you see here are the examples of tree. We take this image for further discussions. First, I want to define the technical definitions of the tree. Tree data structure can be defined as a collection of entities called nodes which are linked together to form hierarchical structure. Here, all the circles are the nodes. All the nodes will contain some data, and that this data can be any type. In our case, A, B, C, D, E, F, G, H, I. Now, I am introducing you some terminology that we use for the tree data structure. First, root. The topmost node of a tree is called root, and it is the origin of the tree data structure. Here, A is the root of this tree, and there must be only one root node in a tree. Next, edge. The connecting link between any two nodes is called edge. Here, this link between A and C is the edge. Similarly, the connecting link A and B is referred as edge. Next, parent. The node which is predecessor of any other node is called parent node, or we can say the node which has child is called parent node. Here, A, B, C, E, G, all are the parent nodes because all of them have childs. Here, A have childs B and C, B have childs, has childs D and E, and C has child F, G, E has a child H, and G has a child I. Next, child node. The node which is descendant of any node is called child. Here, B and C are the children of A. Similarly, D and E are the children of B. F and G are the children of C. H is the children of E, and I is the children of G. Next, siblings. The nodes are said to be siblings or brothers if they have same parents. Here, B and C are the siblings because they have the same parents A, and D and E are the siblings because they have same parent B. Similarly, F and G are the siblings, they have same parents C. Next, leaf or terminal node. A node which does not have any child is called leaf node, or in simple word, a leaf is a node with no child. Here, D, F, H, I are the leaf node because they don't have any child. Next, internal node. An internal node is a node which has at least one child. Here, A, B, C, E and G are internode nodes because A has two childs, V has two childs, C has two childs, E has one child and G has one child. So A, B, C, E and G are the internal nodes and D, H, F, I are the external nodes. That's mean all the leaf nodes of a tree are the external nodes. Next, degree of a node. The total number of children of a node is called degree of that node. Here, the degree of A is 2 because A has two children. Similarly, the degree of B is 2 and C has also 2. The degree of E and G is 1 because both of them has one child. The degree of all leaf nodes is 0 because they don't have any child. Next, degree of a tree is the maximum degree of a particular node it has. In this example, the degree of this tree is 2 because the maximum degree of this tree is 2. For example, let's see this tree. The degree of above tree is also 2 because A has the maximum degree among all the nodes. Next, level. In a tree, each step from top to bottom is called level. Here, the root is level 0. At level 0, the children of root is at level 1. The children of the nodes at level 1 are in level 2. The children of nodes of level 2 are in level 3. Next, depth or height of a tree. Depth or height of a tree is said to be maximum level number plus 1 that are in a branch of a tree. Here, the depth of a tree is 4 because the maximum level number is 3 and we add 1 to get the depth or height of a tree. Next, subtree. A portion of tree which can be viewed as a tree in itself is called subtree. Here, this BDEH is a subtree. Similarly, CFGI is a subtree. Left subtree. The left subtree is a subtree which is formed only by the left nodes of any tree. So here BDEH is the left subtree. Right subtree is formed by the right nodes of any tree. Here CFGI is the right subtree. Next, we are going to define some applications of tree. First application is storing hierarchical data. For example, file system on your disk drive. Second one is organize data for quick searching and inserting and deletion. And third one, tree is used for network routing algorithm.